We saw quantum physics is just mathematical models, but they are considered with some kind of intrinsic proof or evidence. There are flaws and we don't know what it means, but nobody can doubt it. And some physicists even pretend quantum math is treated as the equivalent of Michelangelo's Pietà, a piece of unquestionable art. Quantum physics clear the way to believe we can understand the unknown by brute forcing a math solution. These models can break logic or be incoherent with known physics, it only matters that math checks. As with quantum mechanics, the abuse of calculus is seen in the attempt to solve the dark matter problem. Hundreds of models formally correct, but also chronically incomplete and inconclusive. Indeed, these days we have thousands of new publications, but very often they are held together only by mathematics and statistics. So we can have publications that are meaningless, unverifiable, or with gross mistakes, casting even more shadows on the already staggering peer review. The mathematical solution starts to be good even if math has its own rules, unrelated to the field of application. Even if math doesn't understand physics, so it can calculate something unphysical. And even if math cannot replace physics, because it is a subordinated tool. The unknown is not understood just because it is somehow calculated. And quantum physics seems to work where classical can't because it follows mathematical rules instead of physical ones. So math is not the main problem because the issue comes from how quantum is built. And quantum physics deal with the statistics of reality and needs unphysical laws to work. And we can use some form of teleportation as example. Here we can have the instantaneous change of location with tunneling where the system jumps from A to B without traveling the space in between. Or we can have two entangled systems, A and B, and my action on A have a sudden consequence on B, no matter the distance, and so violating relativity. Teleportation has a physical meaning, but not a mathematical one. So math limits and rules are different from physical logics, and math itself cannot prevent unphysical answers. But also it doesn't teleport. And quantum physics is inferring the teleport from a mathematical result, and if your model allows for teleportation, math can do nothing to stop it. Quantum physics claims evidence the agreement between the mathematical solution and the outcome. And since this math connect two facts, it may seem there is some kind of proof. But connecting two facts doesn't give you a third fact. So this math is not a fact, an explanation, or a demonstration, and everything that follows can be better. Following this arbitrary evidence, quantum mechanics is assumed correct, and actions are taken to demonstrate this agreement. As we see, there is a recursive self-sustaining pattern, so it is almost impossible to see the mistakes from the inside of quantum physics because most of the errors have been already overcome and the unprovable is assumed right. Terms like prove or demonstrate means nothing referred to models. Proof is about facts, but event and model are no facts. And following the scientific method, the only evidence that can be obtained from an experiment or an observation is that your theory is wrong. You assume yourself wrong and you try to disprove your theory because you can never obtain evidence of truth. The only evidence you can get is being wrong. Yet, here, quantum physics assumes itself correct and experiments are carried out to show the agreement. They don't test if it is wrong, they want to prove it true. Now, if I have a model and I don't perform experiments, I can't be disproved. So is my theory correct? Of course not, but there is something more subtle. I know where and how my model works, so I just perform experiments that show my model correct. I cannot be disproved, and I use these results as a proof. Unfortunately, not being disproved doesn't make the model true. And even a consistent agreement with the results doesn't mean your model is right, because consistency comes from physics, and you risk the turkey illusion. On the same page, we have the lack of proof that is not a proof, and this is quite self-explanatory. You must challenge your theory, not take it in on a honeymoon. Best thing can happen to your theory is to hold that any test, but this does not imply that this is true. And if at some point one experiment prove your theory wrong, you did scientific, but your model is wrong. I want to stress out that everything said is not philosophy. It is the very base of scientific method since Galileo, while quantum mechanics remember the Aristotelian axioms that precede and define what reality should be. It is said that quantum physics is meaningless at a macroscopic scale. In other words, classical physics deny quantum effects, but there is an arbitrary consensus to save the theory. And actually, there is no scale at which you can prove quantum mechanics. That's the whole point in the elusiveness. Meaning that in every experiment we can perform, quantum effects make no difference. Even within experiments where quantum effects are allegedly observable, it is possible to give a deterministic explanation, and if I can study the event both through quantum and classics, I'll always choose classics, since it doesn't force me to be unphysical just to handle the event. Quantum physics is inventing reality, taking the facts and deducing something that cannot be verified. It doesn't follow this scientific method, and it is based on math agreements that are mistakenly considered evidence of truth. Quantum mechanics is not physics. It is math about something physical and gives incomprehensible answers through abstract mathematics. There is no proof, understanding, or demonstration. We can make up particles and effects for another century and more without reaching any conclusion, despite the breakthrough is always behind the corner, because quantum mechanics is based on consensus in place of the method, so creativity is the limit. This is the level of awareness we need to regain if we want to make some real instead of quantum progress. Otherwise, we can turn the entire physics into a mess of spooky actions.